I'm going to do some examples from section 5.3, which is called Principles of Counting. In particular, I'm going to show how to do what they call permutations and combinations on the TI-84, where they give some examples of this. If I scroll down in the homework, the permutations thing start with this. With these examples, I want to do, say, number 22, 10p4, which means how many permutations are there of if you have selecting 4 out of 10 objects in a specific order, how many permutations are there? The idea with the permutation, there's a first one, a second one, a third one, and a fourth one, so the order is important. On the calculator, we can calculate 10p4 by entering a 10, and then to get to the 10p4, if I go to Math, and then arrow all the way across to Probability, and then you see this NPR, number 2 there, that's the one we want. And so if I go 10 NPR and then 4 and enter, that gives me 5040 is the number of ways that 4 objects can be selected among 10 in a definite order. Now they put this into a word problem context. So in the homework, this question, say number number 32, say they have 22 members. How many ways can the president, treasurer, and secretary be chosen? So they're choosing 3 people out of 22 in a definite order. The president is first, the treasurer is second, the secretary is third. So this is going to be 22p3. So on the calculator, I can go 22 and then Math, Prob, NPR is number 2, enter, NPR 3, and that's going to tell me that there are 9,240 ways that these officers can be selected for this committee. Now, the contrasting thing is what they call combinations, in which you're selecting a certain number of objects from a group, but the order doesn't matter, and that's called a combination. In the homework, let me do a couple of these kinds of exercises. In the homework, if I arrow down a bit here, this is the notation. Let's do 6C2. So this is selecting 2 objects from a group of 6 in which there isn't a first one or a second one. The order in which these objects are selected doesn't matter. So to do 6C2 on the calculator, I'm going to go 6, and I'm going to go to the same thing, Math, Prob, for probability, but now I'm going to go to the third thing, which is NCR. So what was it? 6, choose 2, so 6 NCR 2, and when I hit enter, there's 15 ways of selecting 2 objects out of 6 if the order of the objects doesn't matter. They have some word problems that use combinations. To do one example of those, if I scroll down a bit, how about this number 48? There's 19 members in some club. 5 are selected at random to go to the state conference. The order doesn't matter how the 5 are chosen. So this is going to be choosing 5 out of 19 objects where the order is unimportant. This is going to be 19, choose 5 on the calculator. I can do this by 19 and then go to Math, arrow across to Probability, arrow down to NCR, 19 NCR 5, and that tells me when I hit enter, there are 11,628 ways that these 5 members can be chosen to go to this meeting.